Hello and good evening everyone. I welcome you all to this first free class of Phoenix 2.0. I believe you all are doing good and having a great time. Well, my name is Khursheed and you can also call me KK sir. Before we move ahead, let me know in the chat quickly if I am audible and visible to each one of you. Let me know in the chat quickly. Let me know in the chats quickly. Let me know in the chats quickly, my dear lovely students. Okay, thank you at the rate of icon. Thank you, beta. So, I believe we are live now. Once again, let me tell you, as you know, this is the first free class for everyone. So, share the stream with everyone, my dear lovely students, and I would want you all guys to mark the attendance by smashing the like button. And also, I would want you all guys to be with me till end of this session. In today's session, we are going to take first free class of organic chemistry, and let me tell you that I will teach organic chemistry from scratch to advanced level, my dear lovely students. So, you have to be very much sincere towards your free live classes. So, stay consistent and you have to trust this, process, and let's make this journey accountable. Let's make this journey count, So, my dear lovely students, welcome once again and welcome aboard. And let's get going without wasting much more time. But before, let me tell you that if you have not enrolled in Phoenix 2.0 yet, enroll as quick as possible. Link is in the description. Click that link so that you will be able to enroll as soon as possible. And let me tell you, the PDF of today's session I will be sharing on my new Telegram channel, and that is t.me/KK Sir Chemistry Class. My dear lovely students, there will be no gap. You have to search it on Google. There is no gap between KK Sir Chemistry Class, but you have to remember that these first two alphabets are in capital form. So, are you excited for today's first free class of organic chemistry? Let me know in the chats quickly. Are you excited, my dear lovely students? Let me know quickly in the chats. Are you excited for first class of organic chemistry? Come on, my dear lovely students. Come on, show some josh in the chats and show some green hearts as well. Come on, dear students. No. It will be 1.5 hours maximum, or it can be of 1 hour only. Come on. Come on, dear students. Okay, without wasting time, let's get started. Let's get started, my dear lovely students. Let me tell you first of all, what is meant by actually organic chemistry? What actually organic chemistry means? As I have promised you that we are going to start this organic chemistry from very low level, that means from scratch, and we will increase the level up to advanced level. Now, so what is actually organic chemistry? First question in our mind should be like this: what actually organic chemistry means? But before that, let me tell you, my dear lovely students, until 19th century, You have to remember these things because this is the history related to organic chemistry. You have to listen carefully and try to make proper notes, handwritten notes. Now, listen carefully. Until 19th century, my dear lovely students, it was believed that the compounds which were isolated directly or indirectly from living organisms. That means the compounds which were directly or indirectly isolated or obtained from living organism means from plants and animals. These compounds which were obtained from living organisms, that means from plants and animals, it was believed that such compounds are known as organic compounds. And remember, the chemistry which deals with the study of these types of compounds or such compounds was known as organic chemistry. So remember, on the basis of this belief, my dear lovely students, that organic compounds are obtained only from living organisms, that means from plants and animals, and cannot be produced in the laboratory. Because what was the belief? What was the belief? That organic compounds are only and only be isolated directly or indirectly from living organisms. That means they cannot be created, they cannot be synthesized artificially, they cannot be synthesized or produced in the laboratory. This was the belief. And on the basis of this belief, Berzelius, try to remember the name, Berzelius in 1815. Berzelius in 1815, my dear lovely students. Try to remember this. This Berzelius in 1815 gave a theory or proposed a theory known as vital force theory, my dear lovely students. Now, if I told you who gave vital force theory, so what will be your answer? Come on, let me know in the chats quickly. Come on, let me know in the chats quickly. What will be your answer? What will be your answer, my dear lovely students? Come on, dear students. Come on. What will be the answer? Who gave this theory, vital force theory? It was Berzelius. But on the belief that organic compounds can be produced only from living organisms, they cannot be produced from what we call, they cannot be synthesized in the laboratory, or they cannot be produced artificially. So this was the belief. On this belief, Berzelius gave a theory, and that theory was what we call vital force theory. Now, dear students, according to this theory, remember, organic compounds can be produced only under the influence of some mysterious forces. under the influence of some mysterious forces, dear students, existing in living organisms. This mysterious force was called vital force. So, what was the statement of this theory? What was this theory all about? Berzelius said that we can prepare, we can synthesize organic compounds, we can obtain organic compounds, but only with the help of or under the influence of some mysterious forces. And these mysterious forces are only exist in what we call living organisms. That clearly indicates, since these forces, these mysterious forces, I mean say vital force, which was finally named as vital force. So these mysterious forces or this vital force as it exists only in living organisms. So we can prepare organic compounds according to this theory only and only in living organisms or from living organisms. So can I say, since such a force cannot be created such a force cannot be created artificially, so it is not possible to synthesize organic compounds. It's not possible to synthesize organic compounds in the laboratory. Now tell me, my dear lovely students, I will be waiting for your response. Tell me, let me know in the chats quickly, what was the basics of this theory? Come on, tell me. Why Berzelius said that these organic compounds cannot be produced, cannot be synthesized in the laboratory? Why Berzelius said that? Why Berzelius said that? Let me know in the chats quickly. Why Berzelius said that? Come on, let me know in the chats quickly. Why Berzelius said that organic compounds cannot be synthesized in the laboratory? What was the reason? Come on, my dear lovely students. What was the reason? Reason was simple. Because Berzelius was having a belief that organic compounds are synthesized only and only from living organisms. On that belief, on this belief, Berzelius made a theory, and the statement for that theory was that organic compounds can be produced only under the influence of mysterious forces, and these mysterious forces he called after that this mysterious force as vital force. That means organic compounds can be produced only because of this mysterious force, and this mysterious force exists only in living organisms. This mysterious force is not present in the laboratory. So this Berzelius said that organic compounds cannot be synthesized in the laboratory as there is no mysterious force. So organic compounds can be synthesized only from living organisms because these mysterious forces exist in living organisms. Now let me know in the chats quickly, is this clear to you? Is this clear to you? Let me know in the chats quick. Let me know in the chats quick, my dear lovely students. You have to be very much sincere. You have to be very much attentive. You have to be very much, responsive when organic chemistry class is there. Is this point clear to you? Show some Josh if this is clear to you. Come on, quick. Show some Josh, my dear lovely students, if this theory is clear to you. If statement of this theory is clear to you. Come on. Quick, dear students. Okay, all right. Now, dear students, have a look. This theory was given by Berzelius in 1815. In 1828, my dear lovely students, that means after 13 years, Friedrich Wöhler, a German chemist, remember my dear lovely students, after 13 years, Friedrich Wöhler, a German chemist, made an interesting discovery. Listen carefully. What was the discovery? Made an interesting discovery. He obtained accidentally, or he accidentally obtained urea, a well-known organic compound. By evaporating aqueous solution of ammonium cyanate. So this is aqueous solution of ammonium cyanate. This is aqueous solution of ammonium cyanate. Upon heating or on evaporation, it rearranges basically to NH2, CONH2. This is known as urea. And this urea is an organic compound. And this organic compound has been obtained in the laboratory from an inorganic compound. Now listen carefully. So, Berzelius said that it is not possible to prepare any organic compound in the laboratory, because to prepare organic compound or to obtain organic compound, we need some mysterious force. And he called that mysterious force as vital force. And this vital force exists only in living organisms. That's why we cannot prepare any organic compound in the laboratory, because in laboratory there is no vital force, there is no mysterious force existing. Is this point clear to you? But my dear lovely students, after 13 years, Friedrich Wöhler, remember the name, made an interesting discovery. And what was the discovery? Discovery was urea got prepared, urea got obtained, but he does not basically deliberately obtain, urea. He accidentally obtained this urea, which is an organic compound. So what was the actual experiment, or what was basically the aim of what we call Wöhler? What was Wöhler actually attempting to do? Have a look. Actually, Wöhler mixed. Listen carefully, because this is history related to the chemistry. Actually, Wöhler mixed, my dear lovely students, this thing. Wöhler mixed what? Have a look. Wöhler mixed AgCNO, that means silver cyanate, its aqueous solution, with ammonium chloride aqueous solution. Ammonium chloride aqueous solution. That means actually he mixed aqueous solution of silver cyanate and aqueous solution of ammonium chloride. When he mixed these two, he wants to prepare what we call ammonium cyanate. He wants to prepare ammonium cyanate, and ammonium cyanate is obtained there. With the formation of ammonium cyanate, Ag silver is precipitated in the form of a white precipitate. Now have a look. When he prepared, his aim was to prepare ammonium cyanate. That's why he mixed this silver cyanate aqueous solution with aqueous solution of ammonium chloride. He first obtained ammonium cyanate, but he obtained this ammonium cyanate in aqueous solution or in the form of aqueous solution. That's why he heated this to evaporate water in it, so as to water is evaporated. So he basically heat this ammonium cyanate, which was in the form of aqueous form. So he simply heated this aqueous solution of ammonium cyanate so as to evaporate water from it. Once water will be evaporated from it, he wants to collect basically anhydrous solid form of this salt, which is known as ammonium cyanate. He thought, I will heat it, water will evaporate, and I will get, ammonium cyanate, solid salt in the form of anhydrous form, That is why he heated it. But because of this heat, due to this thermal energy, what has happened? These atoms rearranged so as to form urea. Atoms rearranged to form urea instead of its dry form. So basically, what was the aim of, Wohler? Aim was to obtain the same salt, same solid salt, but in anhydrous medium. It was the aim of Wohler. But when he heated this aqueous solution of ammonium cyanate, because of thermal energy, there will be rearrangement. That means these atoms rearranged together so as to form urea, which was an organic compound. That means organic compound urea was prepared in the lab for the first time, but not deliberately, but accidentally. Let me know in the chats quickly, is this point clear to you? Is this point clear to you? Let me know in the chats quickly. Come on, my dear lovely students, quick. Tell me. Come on, my dear lovely students. Is this clear? Now, if I asked a simple question to you, write down the question and tell me the answer. What was the first organic compound synthesized in the lab? Come on. Name the first organic compound which was synthesized in the lab. Come on, tell me. The first organic compound which was synthesized in the lab. Tell me the name. Exactly, it is urea. Okay, write down second question and tell me the name. What was the first organic compound synthesized in the lab accidentally? Tell me. What was the first organic compound synthesized in the lab accidentally? Once again, answer is same. Answer is urea. I hope this is clear to you. Now, can I say, my dear lovely students, with the help of this experiment, this Wohler got what we call an organic compound accidentally. But can I say this synthesis gave death blow to vital force theory? Why this synthesis gave death blow to vital force theory? Have a look. So I will write down this synthesis gave death blow to the vital force theory. And clearly demonstrates that no mysterious force is required to synthesize organic compounds in the laboratory. So why this synthesis gave death blow to vital force theory? Because according to vital force theory, according to Berzelius, organic compounds can be produced only from living organisms, because if we want to obtain organic compounds, they can be obtained only under the influence of some mysterious force. As there is no mysterious force in the laboratory, so there will be no, formation or synthesis of organic compound. But this synthesis gave death blow to vital force theory, because organic compound has been obtained here in the laboratory where there was no mysterious force. So that clearly indicates no mysterious force is required to synthesize organic compounds in the laboratory. So there no need of mysterious forces there. I hope this point is clear to you. Now, after this, remember my dear lovely students, after this, the elegant synthesis of acetic acid, my dear lovely students, this is the formula of acetic acid, you know this, by Hermann Kolbe in 1845, and methane by Berthelot in 1856 from purely inorganic sources, drew the last nail in the coffin of the vital force theory. As already due to accidental synthesis of urea in the laboratory, there was already one blow to vital force theory. But after this, my dear lovely students, when acetic acid was synthesized by Hermann Kolbe and methane was synthesized by Berthelot from inorganic sources in the laboratory, then we can simply say, with the help of these, these syntheses simply drew the last nail in the coffin of the vital force theory, my dear lovely students. Now have a look. This is carbon. When it is treated with sulfur, I will balance the reaction over here. When it is heated, it results in the formation of CS2. Then this carbon disulfide, my dear lovely students, on treatment with chlorine, results in the formation of CCl4, dear students. So we are having Cl6 over here, so it is simply S2Cl2 is there. Now dear students, after that, this CCl4 upon heating results in the formation of this thing. This is tetrachloroethylene. As in total there are 8 chlorine atoms here. It is 4 chlorine, then it is twice Cl2. Now this Cl2, C double bond C, Cl2, my dear lovely students, this on treatment with chlorine and water, that means aqueous chlorine, it in presence of sunlight results in the formation of Cl3CCOOH plus, have a look here, total chlorine are 6 in number, there are 3, so I will write down 3 times HCl. Finally dear students, this trichloroacetic acid upon reduction simply, this undergoes reduction and it results in the formation of acetic acid. So have a look, it results in the formation of acetic acid, my dear lovely students. So plus 3 times HCl. Now listen carefully. So acetic acid has been obtained from its constituent elements like carbon, like hydrogen, like oxygen. So it has been prepared in the laboratory for the first time deliberately. So first organic compound synthesized in the laboratory deliberately is acetic acid. So urea was the first organic compound synthesized in the laboratory. Urea was the first organic compound synthesized in the laboratory, but accidentally. This is first organic compound synthesized in the laboratory, but deliberately, and that too from its constituent, elements, from carbon, from hydrogen, and from oxygen. I hope this point is clear to you. Now, due to formation of this one, vital force theory becomes, less relevant now. I hope this point is clear. Now, let me know in the chats, is this point clear to you? You have to remember only this because we have not studied the reaction portion. Once reaction portion is started, everything will be clear. You don't have to mug up these reactions. You don't have to memorize these reactions. I will tell you how actually these reactions occur. So, but right now you have to remember only the experiment which Hermann Kolbe has done actually. Now tell me, is this clear to you? Is this clear to you, my dear lovely students? Is this clear to you? Let me know in the chats quickly. Let me know in the chats, my dear lovely students, quickly. I know today's session is a little bit, related to history as compared to chemistry. So, but this is very, very important. You have to remember, if you want your organic chemistry should be very much strong, then you have to remember this, because I have promised you that we will start organic chemistry from the very scratch, and that too to advanced level. Now, tell me, my dear lovely students, after this, dear students, how methane has been obtained by Berthelot. Have a look. Actually, vapors of carbon disulfide and hydrogen sulfide are passed through hot copper or red hot copper. They are passed through red hot copper. After that, my dear lovely students, it results in the formation of methane and Cu2s. Now have a look. So this methane has been obtained from inorganic, sources. Similarly, this acetic acid has been obtained from inorganic sources. I hope this point is clear to you. So the synthesis of, methane as well as synthesis of acetic acid, these syntheses drove the last nail in the coffin of the vital force theory. I hope this point is clear. Now, let me write down a question over here and you will answer these questions. Question number 1. Name the first organic compound synthesized in the laboratory. Name the first organic compound synthesized in the laboratory. Question number 1. Question number 2, my dear lovely students. Name the first organic compound synthesized in the laboratory deliberately from its constituent elements. And number 3, Name the first hydrocarbon. Means that compound which is made up of carbon and hydrogen. Name the first hydrocarbon synthesized in the laboratory. Write down answers of these questions in the chats. I will check. I will check. I will check. Write down 1 and then answer. Write down 2 and then answer. Write down 3 and then answer. Come on. Come on, everyone. Exactly. At the rate of Puvish, you're exactly correct. 1 urea, 2nd acetic acid, 3rd methane. Exactly. Exactly. Exactly at the rate of Shahjahan, urea, acetic acid and methane. Very good. At the rate of KYS, Harsha, urea, acetic acid and methane. Exactly. At the rate of Jubilee, urea, acetic acid and methane. Great. At the rate of Dora, great. At the rate of Kamling, great, 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 everyone. At the rate of Eugene Knight, great, 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 great. That's great. That's great. That's great. So, my dear lovely students, if you have not enrolled yet, link is in the description below. Just click that link and enroll in our Phoenix 2.0 batch quickly. Come on, my dear lovely students, because we are going to teach everyone, whether it is physics, whether it is chemistry, whether it is biology. Every teacher will teach you from scratch to advanced level. So come on and click the link quickly. Come on, my dear lovely students, come on. So, dear students, after this, have a look, my dear lovely students. Now, finally, with the downfall of what we call vital force theory. Dear students, with the downfall of vital force theory, the term organic pertaining to life lost its original significance. My dear lovely students. However, it was shown that all organic compounds, whether natural or artificial, has essential or contains, or simply we can say contains, essential elements like carbon and hydrogen, and occasionally few other elements like nitrogen, oxygen, phosphorus, sulfur, halogen, etc. So, my dear lovely students, now vital force theory due to downfall of that. Now, the term organic, which was pertaining to life, because we were saying that organic compounds came only from, say living organisms, that lost its physical significance, its original significance. But all those organic compounds, whether they were obtained artificially or they were natural organic compounds, my dear lovely students, they contain carbon and hydrogen. They contain carbon and hydrogen, my dear lovely students, and occasionally few elements like nitrogen, oxygen, phosphorus, sulfur, halogen, etc. That's why, my dear lovely students, organic chemistry, organic chemistry is now defined as that branch of chemistry. Now listen carefully. That branch of chemistry which deals with the study of carbon compounds. Containing usually hydrogen and one or more additional elements like nitrogen, oxygen, phosphorus, sulfur, halogen, etc. So now, my dear lovely students, now what is meant by organic chemistry? Organic chemistry is simply that chemistry which deals with the study of compounds of carbon, which generally contains what? Hydrogen, and sometimes they are having few elements, whether that is one or more than one, and those elements are nitrogen, oxygen, phosphorus, sulfur, halogen, etc. So, my dear lovely students, here you have to remember, dear students, few carbon compounds. You have to remember that few carbon compounds like carbon monoxide, carbon dioxide, metal carbonyls, for example, my dear lovely students, FeCO whole 5, NiCO whole 4, CrCO whole 6, etc. These are the metal examples, few examples of metal carbonyls. Metal carbonates, for example, dear students, Na2CO3, CaCO3, MgCO3. These are the metal carbonates, few examples of metal carbonates. Similarly, my dear lovely students, metal bicarbonates, for example, NaHCO3, CaHCO3 whole twice, MgHCO3 whole twice, etc. My dear lovely students, these are few examples of metal bicarbonates. Similarly, carbides, etc. Carbides, say for example, I can write down CaC2, I can write down Al4C3, we can write down SiC, etc. My dear lovely students, then these carbon compounds, if organic chemistry is simply chemistry which deals, or the branch of chemistry which deals with the study of carbon compounds, then these carbon compounds should have been included. So these carbon compounds should have been included should have been included in organic chemistry. These should have been included in organic chemistry, but my dear lovely students, but are still studied under inorganic, not organic. It should have been included in organic, but it is studied in inorganic chemistry because of their greater resemblances with inorganic compounds. So, dear students, organic chemistry may be more precisely defined as the chemistry of hydrocarbons and their derivatives. Now tell me, my dear lovely students, what are hydrocarbons? Hydrocarbons and their derivatives are basically organic compounds. So the chemistry which deals with the study of organic compounds is known as organic chemistry. But now what are organic compounds? Organic compounds are not now those compounds which are obtained from living organisms only. No. But organic compounds are basically compounds of carbon which usually contains hydrogen. That means these are compounds of carbon except few compounds which basically their properties resembles with that of inorganic compounds. That's why we studied such compounds under what we call inorganic chemistry. So we can simply say organic compounds are compounds of carbon, or we can simply say organic compounds are basically hydrocarbons and their derivatives. And the chemistry which deals with these compounds is known as organic chemistry. I hope definition of organic chemistry is clear to you. I believe definition of organic chemistry is clear to you. Let me know in the chats quickly, is this definition clear to you? Because if this definition is clear to you, then let me know quickly, is this definition clear to you? Come on, quick. Come on, my dear lovely students, tell me, is this definition clear to you? Yes. Now we can simply say these are not the organic compounds because of their resemblances, because of their properties which will resemble much more with inorganic compounds, dear students. Now, dear students, now tell me, can I say, have a look. Have you ever heard about CH4? Answer should be yes. Now, this is what we call methane. Now tell me, my dear lovely students, is methane a hydrocarbon? Tell me, is methane a hydrocarbon? Answer is yes. Now tell me, dear students, if this methane, if we remove one hydrogen from this methane, what will we obtain? We will obtain this one. And what is this? This is methyl, my dear lovely students. And what is methyl? Methyl is basically hydrocarbon radical. It's hydrocarbon radical. Basically, it is the group which has been obtained from hydrocarbon by replacement of one hydrogen, say removal of one hydrogen. So this is an example of alkane. This is example of alkyl. And my dear lovely students, instead of that hydrogen, if I add halogen, same number of halogen, That means if hydrogen is replaced by same number of halogens, what will we obtain? We will obtain CH3X. That means we will obtain alkyl halide. And this alkyl halide is known as methyl halide. And what is methyl halide, dear students? Have a look. Methyl halide is simply hydrocarbon derivative. It has been derived from hydrocarbon. So it is hydrocarbon derivative. Yes or no, beta? Now, my dear lovely students, whether it is hydrocarbon, whether it is hydrocarbon derivative, both are known as organic compounds, and the branch of chemistry which deals with the study of whether hydrocarbon is there or hydrocarbon derivative is there is simply known as organic chemistry. Now, is this point clear to you? Is this point clear to you? You can take another example. You can remove 2 hydrogens by 2 halogens, then you will get CH2X2, that's hydrocarbon derivative. Yes or no? Or you can simply replace 1 or more hydrogens by OH group, then the final product will be hydrocarbon derivative. Now tell me, my dear lovely students, is this point clear to you? Is this point clear to you? Is this point clear to you? Tell me, if I write down this one, look towards this, its formula is C6H6. I can write down like this. It is like this. C, single bond 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 C, and then it's a double bond over here, double bond over here, double bond over here, then 1 hydrogen over here, 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 and 1 hydrogen here. Now look towards this structure. Is this structure hydrocarbon? Tell me. This is known as benzene, resonating structure of benzene. Now tell me, is this structure a hydrocarbon? Quick, tell me quickly. Let me know in the chats quickly. Is this a hydrocarbon? Is this a hydrocarbon? Let me know quickly. Is this a hydrocarbon? Come on, quick. Is this a hydrocarbon? So my dear lovely students, if this is hydrocarbon, if I replace its 1 hydrogen, say for example by 1 chlorine, if I replace, say for example, this hydrogen by 1 chlorine, can I say we will get this one? This is known as chlorobenzene. Tell me, my dear lovely students, this is hydrocarbon. This is hydrocarbon derivative. Yes or no? Yes or no? Now tell me, is this an organic compound? 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 Yes or no? So what is organic compound now? Organic compound is simply hydrocarbon and its derivative. And or we can simply say hydrocarbons and their derivatives are known as organic compounds. Is this point clear? Is this point clear to you? So what are organic compounds? Organic compounds are simply hydrocarbons and their derivatives. I hope this point is very much clear to you. This point is very, very clear to you. Now, dear students, we generally say that organic chemistry is that chemistry which deals with compounds of carbon. Now, second question is now, first question was what is organic chemistry? Now, second question is why carbon is so special. Why we are saying that organic compounds are basically the compounds of carbon. Why carbon is the essential elements of organic chemistry. Why carbon is so special. Answer is this one. Can anyone tell me the answer of this question? Can anyone tell me the answer of this question? Why carbon is so special? Why the essential element of all organic compounds is carbon? Let me know in the chats quickly. Come on, my dear lovely students. Come on. It has many reasons, but you have to remember few. Say for example, reason number 1 is its tetravalency. Reason 1 is its tetravalency. Dear students, listen carefully, listen properly. As you all know that this is the essential element. This is the essential essential element. I mean, say carbon is the essential element. Carbon is the essential element. Let me write down it once again. Carbon is essential element. Essential element of all organic molecules. Now, if we talk about carbon, what is the atomic number of carbon? What is the atomic number of carbon, my dear lovely students? Its atomic number is 6. And what is its ground state electronic configuration? Its ground state electronic configuration is 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. Or you can you can form in this fashion that 1s2, then it's having 2s, which is having 2 electrons, then it is 2p, then it is 2p, which is having 2 electrons, like this. Now tell me, this is the first shell, this is the first shell, and this is what we call a second shell. This is the second shell, and this second shell is its outermost shell. It is its outermost shell. Listen carefully, dear students. Now, as electronic configuration, if you look towards this electronic configuration, it is clear that that outermost shell of carbon contains 2 and 2, 4 electrons. Outermost shell is also known as valence shell. So can I simply say, my dear lovely students, that the electrons present in valence shell, that means the valence electrons of carbon is 4 in number. If valence electrons of carbon are 4 in number, so it needs 4 more electrons to complete its octet. Yes or no? So it needs 4 more electrons to complete its octet. Hence, it is tetravalent. Hence, carbon is tetravalent. Now, my dear lovely students, listen carefully. Remember, now, it is energetically very difficult. It is energetically very difficult for carbon to gain or lose all 4 electrons to achieve nearest noble gas configuration. Nearest noble gas configuration. Because we know noble gas configuration is considered as the most stable configuration. You know that. So if carbon wants to achieve nearest noble gas configuration, either it has to lose these all 4 electrons so that it will acquire a configuration 1s2, which is that of helium, or it has to gain 4 more electrons, 1 over here, 1 over here, 2 over here, so that its electron number will become 10. That means its electronic configuration becomes 1s2, 2s2 and 2p6. That means so as to acquire a nearest noble gas configuration of, that means configuration of what we call neon. But it is very difficult energetically to either gain all 4 electrons or to lose all 4 electrons. That is why carbon combines with other atoms. Carbon combines, my dear lovely students, with other atoms by mutual sharing of electrons. By mutual sharing of electrons. Hence, forms covalent bonds. So carbon forms covalent bonds by mutual sharing of electrons. And you know, whenever there is mutual sharing of electron, covalent bond formation takes place. After that, my dear lovely students, since all the organic compounds contain carbon as the essential element, hence nature of chemical bonding in organic compounds will be covalent. Thus, carbon is always tetracovalent. That is, it forms 4 covalent bonds with other atoms always. Now tell me, my dear lovely students, is this point clear to you? That tetravalent, why carbon is tetravalent? Because it has having 4 valence electrons, and to complete its octet, it needs 4 electrons. That is why it is tetravalent. But it cannot gain all the 4 electrons, or it cannot lose all the 4 electrons to achieve nearest noble gas configuration. That is the only reason carbon combines with other atoms by mutual sharing of electrons and hence forms covalent bonds. But as carbon is the essential element of all the organic compounds, so the nature of chemical bonding in organic compounds will be always covalent, and that is the reason carbon is tetracovalent, means carbon forms 4 covalent bonds with other atoms, my dear lovely students. And carbon can form these 4 bonds, either all these 4 bonds are single bonds, say for example in case of methane, all these 4 bonds can be single bonds, or 2 can be single bonds like this, and there will be one double bond like this. One double bond like this. Have a look. This carbon forms 4 bonds. This carbon forms 4 bonds. This is having 2 single and 2 double. This 2 single and 1 double bond. This is having 2 single and 1 double bond. Similarly, it can form 1 single and 1 triple bond, my dear lovely students. Similarly, it can form 1 single and 1 triple bond. I hope this point is clear. That means it can form all single bonds. It can form few single, few double bonds, few single, few triple bonds, and double and triple bonds are known as multiple bonds. These are basically multiple bonds. I hope this point is clear. I hope this point is clear. This is very, very basic class. I mean, say today we have actually started the class from very scratch. I hope this point is clear to each and everyone. As it is, I mean, say tetravalent, so it can form covalent bonds. Yes or no, beta? It can form covalent bonds, and that too 4 covalent bonds. So one carbon can form 4 covalent bonds, and after that, the question is now, how can it form millions of organic compounds? Now, that is why second thing is its another property, that is, my dear lovely students, catenation. Second is what we call catenation. So remember, carbon forms a remarkable carbon forms a remarkable property of catenation, which may be defined, my dear lovely students, as the ability of carbon atoms to link with one another, by covalent bonds to form long chains, or we can say branched chains, or we can say rings, etc. And my dear lovely students, the property of catenation, mainly depends on the strength of element to element bond. Mainly depends on to element and element bond. Now, if we talk about the elements of carbon family, it's carbon, it's silicon, it's germanium, it's tin, it's lead. We know on moving down the group, size increases and electronegativity decreases. So it is because of this smaller size of carbon that carbon can form very strong carbon-carbon bonds. Very strong. Its carbon-carbon bond is very strong due to its smaller size. That's why, my dear lovely students, its bond energy will be very high. Say for example, if carbon-carbon bond is there, its bond energy is very high, and that is 348 kilojoules per mole. But if we talk about silicon and silicon, that means next element down the group, when we move down the group, property of catenation decreases. That means bond becomes weaker, and that's why bond energy decreases. And bond energy here is 297 kilojoules per mole. Then, my dear lovely students, if we talk about germanium and germanium, bond energy is now decreased further, and it is 260 kilojoules per mole. After that, if we talk about tin and tin, bond energy will be further decreased, and that bond energy is approximately 240 kilojoules per mole. And finally, if we talk about lead and lead, my dear lovely students, bond energy is now only 81 kilojoule per mole. So can I say, on moving down the group, element to element bond strength is decreased basically. When element to element bond strength is decreased, that means catenation order will decrease. That means the power of catenation will decrease on moving down the group. That is why we say carbon, after that it is silicon, after that it is germanium, is approximately same as that of tin, is more than that of lead. So this is what we call the order of catenation. This is the order of catenation. On moving from carbon towards lead, the order of catenation decreases, property of catenation decreases. Reason being that carbon-carbon bonds are very strong because of their what we call smaller size. I hope this point is clear. Now, carbon shows remarkable property of catenation. That's why it can form millions of compounds. It can form long chains with the help of covalent bonds. It can form branched chains. It can form rings. So that is the reason that carbon is so special. I hope this point is clear to each and every one. Now, beta, let's discuss another, that is types of carbon and hydrogen. But before that, let me know in the chats, is this point clear to you? Why carbon is so special? Is this point clear to you? Why carbon is so special? Is this point clear to you? Let me know in the chats quickly. Let me know in the chats quickly, my dear lovely students. Come on quickly. Come on quickly. Come on, my dear lovely students, because we are going towards organic chemistry. Come on, because this was all about, say a little bit history. Now, let's start. Let's get started with another heading, that is types of carbons and hydrogens. Types of carbons and hydrogens. Now, dear lovely students, come on, write down. Carbon atoms are classified on the basis of number of carbon atoms. On the basis of number of carbon atoms. On the basis of number of carbon atoms attached to them. Number of carbon atoms attached to them. And hydrogens are classified by the type of carbon atom, they are attached to. So what is meant by that? Have a look. What is meant by this all? Have a look. Have a look. When we say that carbon is having only hydrogens attached to it, that means when we say there is no carbon which is directly attached, so here it is basically carbon atoms directly attached to them. So directly word is very important. Directly attached to them. Now, when we say that no carbon is directly attached to this carbon, therefore we can say this carbon as zero carbon. What is meant by zero carbon? That no carbon is directly attached to this carbon. But if I write like this, we can simply say that this carbon is directly attached to one carbon. This carbon is directly attached to one carbon. So this carbon is known as primary carbon. Or we can say this carbon is 1 degree carbon. What about this carbon? This carbon is also attached directly to one carbon. So this is also 1 degree carbon. Yes or no, beta? So this is 0 degree carbon or zero carbon? This is 0 degree carbon. Simply, let me write down, let me erase this thing. Let me write down 0 degree carbon simply. Or sometimes this is also known as neocarbon. So this is 0 degree carbon, this is primary carbon. But sometimes we name both of these as 1 degree carbon. So what is the definition for 1 degree carbon actually? Actually 1 degree carbon or primary carbon is that carbon which is directly attached to only one carbon. Carbon which is directly attached to only one carbon is actually primary carbon. But according to NCERT has not given the name zero carbon anywhere. So we will simply combine these both and we will say primary carbon is, or 1 degree carbon is that carbon which is attached to none or 1 carbon directly. So what is primary carbon? You can write down that. What is primary carbon or 1 degree carbon? Primary carbon or 1 degree carbon is that carbon which is attached to none. That means this one, which is attached to none, or which is attached to 1 carbon directly. Which is attached to 1 carbon directly. Have a look. If I write like this, it is still 1 degree carbon. Why? Because it is not attached directly to this carbon, it is not attached directly to this carbon, it is attached directly to only 1 carbon. This is attached directly to only this carbon. That is why this is also known as 1 degree carbon. What about this one? This is also known as 1 degree carbon because it is attached directly to this carbon only. It is not attached directly to this carbon. It is not attached directly to this carbon. So any carbon which is attached to none or 1 carbon directly is known as primary carbon. Now tell me, is definition of primary carbon clear to you? Tell me, is definition of primary carbon clear to you? Come on, tell me. Come on, tell me, my dear lovely students. Come on. At the rate of Yugin Night, this is 0 degree carbon, but our textbook does not say anything about 0 degree carbon. That's why from now onwards, we will call it as 1 degree carbon. Is this point clear to you? Okay. Now, dear lovely students, so this is type number 1. Type 1 is now 1 degree carbon. Both will be named as 1 degree carbon. So 1 degree carbon is that carbon. You please write down these, definitions. 1 degree carbon is simply that carbon which is attached to none or which is attached to only 1 carbon directly. After that, we will be having another type, that is secondary carbon. Secondary carbon, my dear lovely students. Or simply, we can simply call it as 2 degree carbon. So what is 2 degree carbon? Have a look. Have a look. This carbon we know is a 1 degree carbon because it is directly attached to 1 carbon only. This is also 1 degree carbon because it is directly attached to what we call 1 carbon directly. So can I say terminal carbons are 1 degree carbons? Terminal carbons and carbons are always 1 degree carbons. What about this carbon? What about this carbon? This carbon is directly attached to 2 carbons. Directly attached to 2 carbons. So this is known as 2 degree carbon. I hope this point is clear. I hope this point is clear. So what is 1 degree carbon? Which is attached to none or 1 carbon directly is known as 1 degree carbon. And carbon which is attached to 2 carbons directly is known as secondary carbon or 2 degree carbon. Is this point clear? After that, third type is 3 degree carbon or tertiary carbon. Third type is tertiary carbon. Tertiary carbon or 3 degree carbon. Third type is tertiary carbon or 3 degree carbon. What is meant by tertiary carbon? Have a look. Have a look. If I talk about this, what is this? 1 degree carbon. What about this? 1 degree carbon. What about this? 1 degree carbon. What about this? This is 2 degree carbon because this is attached directly to 2 carbons. What about this, my dear lovely students? What about this? This is directly attached to 3 carbons. Directly attached to 3 carbons. That means this is a tertiary carbon or this is a 3 degree carbon. Now tell me, is 1 degree carbon, 2 degree carbon, 3 degree carbon clear to you? Is primary carbon, secondary carbon, tertiary carbon clear to you? Is 1 degree carbon, 2 degree carbon, 3 degree carbon clear to you? Come on, tell me. Come on, let me know in the chats. Be very much attentive towards the class because it seems that this is very easy. But when your NEET exam is there, easy questions, you cannot, answer easy questions at that time because the problem is not in that question is easy. Problem is in our sincerity level. That is the reason at that time we cannot answer the question. After that, another type of carbon is quaternary. So fourth type of carbon is quaternary carbon, also known as 4 degree carbon. Now what is this 4 degree carbon? Very simple. 4 degree carbon is very, very, very simple. It is that carbon which is directly linked to, directly attached to 4 carbons. So this is first of all 1 degree carbon. This is first of all 1 degree carbon. This is also what we call a 1 degree carbon. This is also 1 degree carbon, because these are terminal carbons. These are the carbons which are attached directly to one carbon only. But what about this, my dear lovely students? What about this? This is the carbon which is attached to 4 carbons directly. So this is a quaternary carbon, or this is 4 degree carbon. Yes or no? Yes or no, my dear lovely students? Now, dear students, have a look. We have written over here, carbon atoms are classified on the basis of the number of carbon atoms directly attached to them. I hope this point is clear now. Second, hydrogens are classified by the type of carbon atom they are attached to. That means, if this is 1 degree carbon, if this is 1 degree carbon, the hydrogens attached to 1 degree carbon is known as 1 degree hydrogen. So can I simply say this is 1 degree hydrogen? Similarly, this is 1 degree hydrogen, this is 1 degree hydrogen. Why? Because this is the hydrogen which is attached to 1 degree carbon. So hydrogens are classified on the basis of type of carbon to which hydrogen is attached. If hydrogen is attached to 1 degree carbon, hydrogen is known as 1 degree hydrogen. So how many 1 degree hydrogens are there? Tell me. How many 1 degree hydrogens are there? 1, 2, 3, 4, 5, 6. Yes or no? Similarly, dear students, the hydrogen which is attached to secondary carbon is known as 2 degree hydrogen or secondary hydrogen. Similarly, dear students, the hydrogen which is attached to 3 degree carbon is known as 3 degree hydrogen or tertiary hydrogen. But we cannot say hydrogen attached to quaternary carbon is known as quaternary hydrogen. Why? Because we cannot attach carbon, we cannot attach hydrogen to this carbon, as it has already formed 4 bonds. If we attach hydrogen to this carbon, carbon becomes pentavalent, which is not possible. So how many types of hydrogens are there? 1 degree, 2 degree and 3 degree. How many different types of carbons are there? 1 degree, 2 degree, 3 degree, 4 degree. That means carbons are of 4 types, but hydrogens are of 3 types. Is this point clear? Let me know in the chats. If this point is clear, then I will give you the question and you will let me know the answer in the chats quickly. If this is clear to each and every one, let me know the answer in the chats. Question is, count 1 degree carbon, 2 degree carbon, 3 degree carbon, 4 degree carbon, 1 degree hydrogen, 2 degree hydrogen and 3 degree hydrogens in the following species. In the following species. Example number 1, CH3, CH2, CH3, then it is C, CH3, CH3, CH3. Come on, quick. Be very much fast. Tell me the answer very fast. Tell me the answer very, very fast. My dear lovely students, come on quick, be very much fast. Come on, tell me the answer of these 2 questions only. I will be waiting. I will be waiting. You have to tell me 1 degree carbon. You have to tell me 2 degree carbon number. You have to tell me number of 3 degree carbons. You have to tell me number of 4 degree carbons. And after that, 1 degree hydrogen, 2 degree hydrogen. After that, 3 degree hydrogen. Come on, quick. Similarly, 1 degree carbon, 2 degree carbon, 3 degree carbon, 4 degree carbon, 1 degree hydrogen, 2 degree hydrogen, and 3 degree hydrogen. Come on, dear students, tell me, quick. Come on, I am waiting for your answer. Tell me the answer of this question. Tell me the answer of this question. Which type of carbon is this? 1 degree carbon. What about this? 2 degree carbon. What about this? 3 degree carbon. What about this? What about this? 1 degree carbon. 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 What about this? 4 degree carbon. So how many 1 degree carbons are there? 1, 2, 3, 4, 5. Terminal carbons. 1, 2, 3, 4, 5. So 5. How many 2 degree carbons are there? Only 1. How many 3 degree carbons are there? Only 1. How many 4 degree carbons are there? Only 1. How many 1 degree hydrogens are there? 1, 2, 3, 4, 5 1 degree carbons are there. They are having 3 hydrogens. That means 15 hydrogens are there, which are 1 degree. How many 2 degree hydrogens are there? 2 hydrogens are 2 degree, because hydrogens which are attached to 2 degree carbon are known as 2 degree hydrogen. What is meant by 3 degree hydrogen? Hydrogen which is attached to 3 degree carbon. So that is, it is only 1 hydrogen. Now, tell me, is this clear to you? Is this clear to you? Let me know quickly in the chats. Is this clear to you? Can you find 1 degree carbon, 2 degree carbon, 3 degree carbon, 4 degree carbon, 1 degree hydrogen, 2 degree hydrogen, 3 degree hydrogen easily? Can you count these carbons and hydrogens easily? Can you count these carbons and hydrogens easily? Come on, tell me. If your answer is yes, then let me know the answer of this question. I will be waiting for this answer. I will be waiting for this answer. Come on. I will be waiting for this answer. Come on, quick. Come on, tell me the answer of this question. Quick. Tell me the answer of this question. How many 1 degree carbons are there? How many 1 degree carbons are there? How many carbons are 1 degree in this case? At the rate of Eugene Knight is saying 1 primary. At the rate of Mahalakshmi is saying 1 primary. At the rate of Pujari is saying 4 primary. At the rate of Puish is saying 1 primary. That is why I was always saying to you that whenever you find that question is very easy, it's not always easy. Sometimes easy questions, we did silly mistakes in easy questions. Have a look how you people have done silly mistake over here. Have a look. If you talk about this carbon, can I say this carbon is 1 degree carbon? Yes or no? If you talk about this carbon, what is this carbon? Have a look. It's attached directly to this carbon as well as this side carbon. That means it is 2 degree carbon. What about this carbon? This carbon is attached only on one side, directly to the carbon. This is not the carbon. So this is also 1 degree carbon. What about this carbon? This is also 1 degree carbon. What about this carbon? This is also 1 degree carbon. So 1 degree carbon is not only 1. 1, 2, 3, 4. There is 4 carbons which are 1 degree carbons. Is this point clear to you? Is this point clear to you? Because many students have given me the wrong answer. Is this point clear to you now? So how many carbons are what we call 1 degree carbons? How many carbons are 1 degree carbons? Now, are you getting me now? So, 1 degree carbon is simply that carbon which is attached directly to one carbon only. Because this is not the carbon. This is nitrogen. This is attached to one carbon only. I hope this point is clear. So this is 1 degree, 1 degree, 1 degree, 1 degree, and this is 2 degree. That means 2 degree is only 1. There is no 3 degree. There is no 4 degree. How many 1 degree hydrogens are there? This is having 3. This is having only 1 hydrogen. This is having only 1 hydrogen. This is having only 1 hydrogen. So 1, 1, 1 and 3. 3, 1, 1, 1. That means 6. 6 hydrogens are there, which are what we call 1 degree hydrogens. This having 3, this forms 1 bond, 2 bond, 3 bond, and 1 is hidden hydrogen. Similarly, it forms 1 bond, 2 bond, 3 bond, but carbon forms 4 bond in total, so 1 hydrogen is hidden. So 1 hydrogen, 1 hydrogen. Similarly, 1 bond, 1 bond, 1 bond, so 3 bonds are there. 1 is hidden hydrogen. So write down hydrogen there. So 1, 1, 1 and 3. 1, 1, 1 means 3. 3 plus 3 is 6. How many 2 degree hydrogens are there? Have a look. This is 1, 1, 1, 2, 3, 4. This carbon forms 4 bonds. So there is no hydrogen. So there is no secondary hydrogen. As no tertiary carbon is there, so there will be no tertiary hydrogen as well. Now tell me, my dear lovely students, is everything clear till now? Is history clear to you? Do you know what was the definition of organic chemistry before? And now, what is the definition of organic chemistry now? Similarly, Berzelius gave which theory? And what was the first organic compound synthesized in the lab? What was the first organic compound synthesized in the lab from its constituent particles? What was the first hydrocarbon synthesized in the lab? I hope everything is clear to you. Now, my dear lovely students, this is all about today's session. So, thank you all for your patience, my dear lovely students. Thank you all. Thank you all, my dear lovely students. Thank you very much. But let me tell you, my dear lovely students, let me tell you, if you have really enjoyed the class, then don't stop here. Follow me on Unacademy, my dear lovely students, and try to attend every live class. Try to attend every live class. Because, my dear lovely students, you have to remember, you have to attend every live session, my dear lovely students, because you have to be very much disciplined. You have to stay disciplined, because consistency, not intelligence. Consistency, remember, not intelligence, is what creates NEET toppers, my dear lovely students. So once again, welcome to Phoenix 2.0, my dear lovely students. This is not just another batch. Let me tell you, this is your comeback story, and that's my promise to you. That's why, if you have not enrolled in this batch yet, enroll as soon as possible. Link is in the description. You just click that link and join this batch as soon as possible. I will see you in the next class. But let me tell you, how will we basically going to study organic chemistry? First of all, we will simply, in next class, we will try to complete what we call how to calculate number of sigma and pi bonds, how to calculate hybridization, how to calculate number of bonding electrons and number of non-bonding electrons. That means that from scratch, we will try to complete that scratch and will level up, my dear lovely students. So we will try to complete organic chemistry according to, my dear lovely students, according to your NCERT text. Some students feel that paper was difficult. Now no need to study NCERT. No, my dear lovely students, NCERT is always there. NCERT is very, very, very important book. But we have to not only rely on NCERT textbook, but we have to be very much, advanced as well. So this is all from my side. Thank you and God bless you all. We'll meet in now next batch and that in next session, and that next session will be on Unacademy app. Till then, take care, bye bye, and God bless you all. Take care.